So now we are going to look at translation, which is happening in the cytoplasm. And we need to find the ribosomes. And ribosomes are made of two subunits, a large subunit and a small subunit. And the mRNA is going to arrive out, squeezed itself out through the nuclear pores, and it's going to line up with its bases at the boundary of the two subunits in the ribosome. So here's our mRNA. It's come through from the nuclear pore. And you can see that it can fit, the ribosome can fit 6 bases at any one time. And that's really helpful because we're going to read the message of the mRNA in groups of 3 called codons. And 3 bases at a time is what's going to be read. And the way it gets read is by using a molecule called tRNA. tRNA floats around in the cytoplasm. There's lots of different tRNA molecules. They're kind of clover leaf shaped, but I'm going to draw them like this. And the job of a tRNA, T stands for transfer, is it's going to transfer amino acids, which are also in the cytoplasm, floating around. It's going to transfer amino acids by attaching them to one part of the tRNA and bringing them to the ribosome. But they don't bring them in any old order. They bring them according to the bases that are on the mRNA, the codons. So at the very end of each tRNA molecule, opposite to where the amino acid is attached, you have an anticodon. So this tRNA might be the anticodon to this second codon here. So it would be G to match the C, then a U, and then another G. And there is a way of telling what amino acid this codes for. And this one actually codes for the amino acid called histidine. So this tRNA with an anticodon GUG always attaches to a histidine. And if we want to match AUG, we are going to need U, A, C as the anticodon on this tRNA, and that always brings the amino acid methionine. So into the space, the sort of structural scaffold of the top of this ribosome here, we will be able to fit in the tRNA with its anticodon, U, A, C. And attached at the top will be the amino acid methionine. And then above this one, we will be able to fit in G, U, G, and the tRNA here with its amino acid histidine. And now we've got them really closely aligned in this structural sort of factory for making proteins. They're very close together. So this is kind of where the magic happens, and an enzyme joins these two amino acids together. And when you join amino acids together, you make a peptide bond. And that is where the phrase polypeptide comes from, because we end up with many amino acids joining together with many peptide bonds, making a polypeptide. So we've used the 2 codons, matched them to our anticodons, aligned our amino acids according to the original message, which was according to the message in the DNA. We've joined them together. All we have to do now is have this whole ribosome track one more codon along the mRNA. It would read the next 3 bases here, 1, 2, 3, and the new tRNA would come in, bringing the next amino acid and therefore elongating the polypeptide. So eventually we will end up with ribosomes like this with mRNA attached, and you would see coming out of the back of the ribosome a long chain of amino acids, all in the order as dictated by the code on the mRNA. And that is translation.